Okay, Chapter 2 review. The first thing that we are going to review is absolute value. And like it says right here, the absolute value of a number is never negative. So the absolute value of 5 is 5. The absolute value of -5 is also 5. So you always look at the number, no matter what the sign is, and that's always your absolute value, and it's going to be a positive. Okay, so for this first problem right here, what is the absolute value of 1/2, Dominic? 1/2, very good. All right, now, whenever you have a negative sign on the outside of the absolute value bars, no matter what, you have to carry it into your answer. No matter what, it has to stay with the problem. And then I just asked myself, okay, what's the absolute value of 3? 3. So because I have that negative sign on the outside, it has to stay with my answer. All right? Again, what do I have on the outside of the absolute value bars? A negative sign. So no matter what, I have to write that negative in my answer. And then what is the absolute value of -8? 8. So I just write that right beside my negative sign. And that is my final answer. Okay, those are absolute values. All right, the next thing that we are going to review, which is a huge thing in algebra, it's adding and subtracting positive and negative numbers, okay? Adding and subtracting positive and negative numbers. So I want you to write these down. Same signs, add the numbers together and keep the sign. Different signs, subtract the two numbers and take the sign of the biggest number. And every number has a sign, and that sign is directly in front of the number. All right, so when we have the same signs, that means I have two numbers, so like -2 and -2. Now, we're going to look right down here at this statement where it says every number has a sign, and that sign is directly in front of the number. Because people get caught up. They say, but that's -2 minus 2. No, every number has a sign, and that sign is directly in front of the number. So if I have the same signs, I'm just going to add the two numbers together, which is 4, and I keep the sign that they have. Okay? Now, when I have different signs, like let's say I have -5 plus 4. Again, every number has a sign. That sign is directly in front of the number. So 5 sign is a minus, 4 sign is a plus. So what I want to do is I want to subtract those numbers. I always want to do the biggest one minus the smallest one, even if they're in opposite order. So I do 5 minus 4, which is 1. And I'm going to take the sign of the biggest number. Well, my biggest number is 5, so I look to find out what sign it is, and I know it's going to be a -1. Okay, so let's use the sayings that we just learned. Same signs, add and keep. Different signs, subtract and take. So let's look at this first number here. I have 7 plus -3. Danielle, tell me, is 7 positive or negative? Positive. But you say, but Ms. Ruber, there is no sign in front of that number. Exactly. When there is no sign, it's always positive. Okay? So I have a +7 and a -3. So I know I have different signs. So I need to subtract the numbers. 7 minus 3 is 4. And I take the sign of the largest number. 7 is bigger than 3, and I know 7's positive. So my answer is going to be +4. Okay? Next problem. Tommy, do I have same signs or different signs? Different because the 8 is negative, the 2 is positive. So what am I going to do? 8 minus 2 is 6. And I'm going to take the sign of the largest number, which is negative. Perfect. Okay, now we've got more than one number. So, I'm sorry, more than two numbers. So we've got 3 of them. So we're going to do 2 at a time. So let's focus on these two first, okay? Dominic, do I have the same signs or different signs? Different signs, all right, so I'm going to do what? Subtract, which gives me 2, and is it going to be a positive 2 or a negative 2? Perfect. All right, now I'm going to do plus negative 6. All right, Devin, do I have same signs or different signs? Different, because I have a positive 2 and a negative 6, so I want to subtract. Danielle, what do I get when I subtract 6 and 2? Negative 4, very good. She kept the negative sign, or she took the negative sign because 6 is the biggest. Okay, so the next example, they just want us to do some more of these, all right? So let's look at this first one here. Negative 6 minus 3. First of all, every number has a sign, and where is that sign? In front of the number. So I look at 6 and I see it is negative. I look at 3 and I see it is negative. But you said, Miss Reber, you just said negative 6 minus 3. So how is that possible? That's just how you read it. You could also read it as negative 6 plus negative 3. Either way. But you just always have to look for the sign that is in front of the number. And that tells you. So now I look, do I have same signs or different signs? Same. So what am I going to do with these numbers? Add them. 6 plus 3 is 9. And I keep the sign that they both have, negative. All right. Same signs or different signs in this next one? Same. So my answer is going to be what? Negative 19. Perfect. All right. Okay. Here we go. We've got a little curve ball coming our way because I have negative 15 minus negative 6. Now, anytime you see two negative signs directly beside each other, this is what you're going to do. Take it and change it to a big plus sign. Two negatives side by side always, always, always equals a positive. Always, no matter what. Two negatives side by side always equals a positive. So what I have here, I had negative and negative. So this is what I like to do. I like to connect them, and we make this parenthesis a plus, because there's always going to be a parenthesis in between them. Okay? So now I look. Do I have same signs or different signs since I changed that? Different. So I just subtract and take. 15 minus 6 is 9. And I need to take the sign of my biggest number. 15 is my biggest, so I take a negative. Okay? Now, I've got three numbers. Again, you want to do it two at a time. So let's do these two. What do you see, red flag, that you have got to change? Two negatives. Let's make it a big old positive sign. Okay? Now, I have different signs or same signs? Different. So I do 4 minus 3, which is 1. Take the sign of my biggest number, which is negative. And then I do negative 1 plus 7. Same signs or different signs? Different. So I subtract. 7 minus 1 is 6. Take the sign of my largest number, which is a positive. So my answer is positive 6. All right, there should be sirens going off in your head. Red flag, a curveball's coming my way. What do I have to do before I do anything? Make the two negatives a what? Positive. Very good. So I make this a big plus sign here. Anything else that I need to change? Nope, everything else looks good, right? Because there's no two negative signs. So we're just going to start this two at a time. 5 minus 7. Is that same signs or different signs? Different, because look, the 5, it doesn't have a sign at all, so I assume it's positive, always. Positive 5 minus 7, or the positive 5 plus negative 7. So I subtract, which is 2. Take the sign of my biggest number, which is negative. So now I have negative 2 plus 4 minus 10 plus 5. I'm going to do my next two. Which are these? Same signs or different signs? Different. So we subtract, and I get 2. Take the sign of the biggest number, which is a positive. Okay, now these two. Same signs or different signs? Different. So I subtract, which is 8. Take the sign of my biggest, which is negative. All right, very good. Subtract and take. Okay, so the next thing that we're going to work on is multiplying and dividing positive and negative numbers. Now, these rules are different. So with our addition and subtraction, we had same signs, add and keep, different signs, subtract and take. But when you are multiplying and dividing, you can use the even and odd rule. It's the easiest way to do it. You will always know what your answer is going to be by counting up how many numbers you have, okay? Or how many signs you have, I'm sorry. So, what I can do is if I had a problem like this, let's say I had -2 times -2 times -2. I can count up how many numbers I have that are negative. 1, 2, 3. If that number is odd, I automatically know my answer is going to be a negative. But if that number is even, I automatically know my answer is going to be positive. That way, go ahead, count up your negative signs. If you have an even amount, I know, all right, no matter what, my answer is positive. I can totally ignore the signs now and just multiply these like I would regular numbers, okay? Or if it's an odd amount of negative signs, your answer will be negative. All right, so let's start by doing that. Let's count. In this first problem, how many negative signs do I have? How many? 1. Is 1 an odd number or an even number? Odd. So I know no matter what, my answer is going to be negative. Now that I have what my sign is going to be, all I got to do is multiply these like regular numbers. 9 times 3 is what? 27. That's my answer. Okay, let's count up. How many negative signs do I have in this second problem? 2. All right. And when I have an even amount of negative signs, what's my answer going to be? Positive. So let's just multiply. 8 times 1/2, or basically 1/2 of 8 is 4. 4 times 6 is 24. Okay, now, here we go. We got a little tricky. -3 to the third power. So I'm going to write it out just like this. -3 times -3 times -3. How many negative signs do I have? 3. So what's my answer going to be? Positive or negative? Negative, because that's an odd number. What's what's 3 times 3? 9 times 3 is 27. Okay? All right, count these up. How many negative signs do I have? 4. So what's my answer going to be? Positive or negative? Positive, so I just multiply. 2 times 3 is 6. 6 times 4 is 24. Times 1 is 24. All right, so now they want me to find the product when I have a variable in there or a letter in the problem. So we're still going to follow the same rule that we just learned. If there's an even amount of negative numbers, my answer is what? Positive. If there's an odd amount of negative numbers, my answer is negative. So let's count up. In this first problem, how many negative signs do I have? 2. So that's an even number, so I know it's going to be positive. Now I just multiply. What's 2 times x? 2x, exactly. Because there is nothing to multiply there because I don't know what x is. Now if they would have said x is 4, I could have plugged that in and figured out what it was going to be. But they didn't tell me what it was, so I just write them side by side. Okay? Let's do the next one. How many negative signs do I have? 2. So what is my answer going to be? Positive or negative? Positive. What's n times n? N. And then because I have two of them, I write an exponent, squared. Okay? That's exactly. Anytime you have the same letter, all right, and it's being multiplied by itself, you just count up how many of those letters you have, and you make it the exponent. Okay? All right, so the next one. Let's do this. Let's count up how many negative signs. How many negative signs do I have? 3. So what's my answer going to be? Negative. All right? So I write negative, and I write my 4, and then how many x's do I have? 3. So I'm going to write 4x cubed with a 3 there. Okay? Okay? Using the distributive property. Okay, I always like to say the distributive property. What if I came to class and I had a bag of candy and I said, Danielle, you can have this bag of candy. Everybody else in the class would say, what about me? That's not fair. I want some candy, okay? That is the distributive property. Whatever is on the outside has to be distributed to everything on the inside, or it's not fair. It's not fair for me to come and give Danielle candy and ignore the rest of you. I need to give everybody candy, okay? That is distributive property. So whatever is on the outside of parentheses, it can be in the front of the parentheses or the back of the parentheses. It has to be distributed to everything inside parentheses, okay? Distributive property is always multiplication. So I look at this and I say, okay, 3 times x. What's 3 times x? 3x. And then not only do I have to distribute the 3 to that, I've got to distribute it to the 1 as well. I keep my sign here. What's 3 times 1? 3. So this is my final answer. Okay? So let's do this one now. Now, I said it can be on the front, what you have to distribute, or the back. It does not matter. So here it is on the back. I need to distribute it still to everything. So what's 7 times x? 7x. What's, and then I keep my minus sign, 7 times 2 is 14. All right, let's do this next one. It's at the back, so I distribute it to everything. What's x times 2? 2x. And you always want to write the number first. So y'all said that right. Now, what's x times 5x? How would I write that? 5x squared. Because I've got 2 x's, so I just write that x, and then I tell you how many I have by saying an exponent. Okay? All right. Now I need to distribute what? The a to everything inside. So a times 2 is 2a. And keep my sign. A times a is what? A squared. Very good. All right, like terms, okay? Like terms. Whenever, okay, this is what I like to say here. When you have like terms, all right, that means that they have something in common. When you have a friend, you guys have something in common. That's what makes you friends. That's what brings you together, okay? When you and that friend get together, let's say you like going to the movies. That's why you're friends. So you both go to the movies together. When you go and you get together, does that mean that both of you like going to the movies, that changes? No, it's the same. Because whatever makes you a like term or a common friend stays the same whenever you get together. It doesn't automatically change. So like terms, okay, have something in common. So like 2x and 7x would be like terms because they both have a what? An x, exactly. So I can add them together and I can get 9x. Now, what they have in common did not change. I did not make that 9x squared, okay? When you are adding and subtracting like terms, whatever they have in common always stays the same. Okay, the constant or a constant is a number with no variables. So a constant could be 5, 10, 100, a million. Those are all constants because they have no variables. Now, the number in front of a variable, so in front of a letter, is called your coefficient. And we already went over this. Like terms have the same variable, and also that variable has to be raised to the same power. So if I had 2x plus 2x squared, you say, oh, but they both have x's. But it's different because this has 1x and this has 2. So they are not like terms. It has to be identical in order for them to be like terms to be added together. Okay? So they want us to simplify by combining or adding like terms together. So I've got to find what my like terms are and then add them together. Anytime you see a letter or a variable, all right, with no number in front of it, it is always 1. So write your 1 there, okay? Are these two terms like terms? Do they have something in common? They both have an x, so I know they're like terms, okay? So 4x minus 1x is what? 3x, exactly. And I keep that like term just like it is. All right? Now, what are my like terms in this problem? 5x squared and 3x squared. Does negative 7 have a like term? Nope, he doesn't have any friends, so he's just going to have to stay by himself. 5x plus 3x, I'm sorry, 5x squared plus 3x squared is what? Perfect, 8x squared. I keep that like term. Since 7 does not have any like terms, I just attach him to the back. He's lonely. Oh, okay. Now, look at this problem right here. What do you see I have to do? We just learned about it a few examples ago and when I gave the candy illustration. Distributive property, exactly. I've got negative 4 times 1 and negative 4 times negative 2x. So I leave my 1 here. What's negative 4 times 1? Negative 4. What is negative 4 times negative 2x? Positive 8x, exactly. Now I need to add like terms. What are my like terms? 1 and 4, exactly. Do they have the same sign or different signs? Different, so I subtract and take. 4 minus 1 is 3. Take the sign of my largest number, which is negative. All right, negative 3 plus 8x. All right. Okay. Keep, flip, and change, KFC. This is when you are dividing by a fraction. There is no such thing as dividing by a fraction, okay? You only ever multiply by the reciprocal. So anytime you see a number and it's being divided by a fraction, what you do is you keep the first fraction or first number, 1/2. Flip the second fraction. So I make this 4 over 3 because it was 0 over 4, and change the sign to multiplication. And then you just multiply straight across. 1 times 4 is 4. 2 times 3 is 6. And I would obviously have to reduce that to 2 over 3. Okay? Keep, flip, and change. Anytime you see a dividing by a fraction. All right? So let's do this one. KFC. What does the K stand for? Keep. So I keep my first term, 6t. Flip is the F, and it's the second one. So I flip the second term, and I change my sign. Now you say, but that's not two numbers, or that's not two fractions being multiplied. Okay, let's make 6t a fraction. Just put it over 1. So 6t times 2 is what? 12t. And what's 1 times 1? 1. So I could write this as 12t, right? Because I don't need to write it over 1. Okay? KFC, keep. So I keep negative x over 12. Flip. Well, you say, but 3 is not a fraction. How do I flip a number? Always make it a fraction. 3 over 1. Now I can flip it because I just say 1 over 3. And change my sign. So now I just multiply straight across. Negative x times 1 is negative 1x. 12 times 3 is 36. Okay? Keep, flip, change. So I keep negative 2/3. Flip negative 9 over 4. And change. What's negative 2 times negative 9? How many negative signs do I have? So it's going to be a positive. And then what's 3 times 4? 12. And then I would obviously need to reduce that, so I can divide by 6, and I get 3 over 2. Okay? All right, so that is the end of Chapter 2 review.